Welcome to our next project. And this one is going to be the coolest and most real-world project so far. So we're going to apply everything that we learned so far, including advanced stuff like functions, arrays, and object-oriented programming. We will also learn some new stuff, like how to use geolocation and how to use third-party libraries in our project. But even more importantly, we will also learn how to actually plan a project. Because building a project is not just writing some code, it's also about thinking and taking decisions and solving problems. And so that's something I really want to teach you so that eventually you will be able to build applications on your own. So in this section, we're going to build the biggest and coolest project yet. And as always, let's start by looking at the finished project so that we can get a feel of what we're going to build here. And so this is the Mapty application. So you have just a small sidebar here on the left side, and then the main part of the application is this huge map. And so this map is actually loaded from a third-party service. And so in this section, you're going to learn how to do that. And also the position is actually automatically obtained by the browser using geolocation. So let me turn this off here for now, the geolocation. And now I will reload. And then the browser will ask me here if it is allowed to know my location. So probably you have seen this here in other applications. And so you will learn how to do this yourself now. So I click allow, and then JavaScript will fetch my position, and it will then also load the map on my current position. Now the goal of this application is for me to log my workouts. So let's say I work out here downtown of the city. So here I have this form where I can input my workout. So here's the type, which is going to be running for now. Then let's say I have 5 kilometers in 20 minutes and with 175 steps per minute. Then I hit enter, and then you see it prints here nicely on the sidebar, and also on our map we got this pin together with this pop-up. Alright, and of course we can do another one. Let's say I went cycling here a bit in the mountains. So here I can choose a different type. So this application allows us to log running and cycling. And now watch what happens here to this last value. So it changes from step to minutes to an elevation gain. So let's say I did 50 kilometers in 5 hours and an elevation gain of 400 meters. And so you see that now I get this pop-up here with cycling. Let's just do one more. Let's say over here, which is another nice spot to go running. And this actually has to be running again. And let's say 180 steps per minute. And now what's cool about this, let's say I have activities all over the place. Then I can just click here and it will automatically move the map to that workout. Okay, so that's really nice. And I think this looks like a real nice real world project. And we're going to have a lot of fun building this one together. Of course, it could be even more real world. For example, we could be able to trace whole lines or polygons here on the map. But as always, I wanted to keep it simple here and focus mainly on the learning and on just implementing some other features that are also pretty cool, I believe at least. Another thing that is special here is that actually when we close this app and reload it, so let's just reload, it will basically keep its state. So you see that the workouts are still here and they're also still on the map. So you see, it's still everything here, even after we basically close down and open it again. And of course, this also works if I copy it, open another tab, and so here it is. Here is all the data. So essentially, this data about the workouts is going to be stored in the browser. And then each time we load the page, we will read the data from the browser. And so that's yet another really cool browser API that we're going to learn about here in this project. All right, and now that we have a broad overview of how this application works, let's quickly take a look at our starter files here one more time. So this is the JavaScript, and once again, I already have my elements pre-selected here, so we don't have to waste time with that. Then here we have the style, and as always, you can have some fun by going through that. Then here the HTML file, which is going to be important because we will need some code from here. And then you will also see that I have this flowchart here for this application and also a diagram for the architecture. But I will not look at this flowchart for now, because actually in this project, I will explain you exactly how to come up with a flowchart like this. And in fact, that's going to be the topic of the next lecture. And so let's move there right now. Now, before we write a single line of code, we first need to plan this project, because this one is a little bit more complex than the other projects that we have been building. So until now, we have always simply started to code, but without much thought about the features or the architecture before writing the implementation itself. I mean, we actually did use a flowchart a couple of times, but I always simply provided that flowchart and we never did it together. So we never planned an application together. So in the real world, it's very important that you always start with a planning phase before building any project, because otherwise you're setting yourself up to a lot of confusion and problems down the road. So to avoid all that, we will now do the planning of the Mapty project together. And so then you will get a feeling of how it works. Now, there are many different ways of planning a project, but I'm going to show you my favorite process here, which works great for many small and medium-sized projects. So I always like to start out with a concept called user stories. And many companies and teams use this idea of user stories, so you will see this everywhere when you start working on a real developer job. So, a user story is basically a description of the application's functionality from the user's perspective. And then all the user stories put together will clearly describe the functionality of the entire application. So user stories are basically a high-level overview of the whole application, which will allow us developers to determine the exact features that we need to implement in order to make the user stories actually work as intended. Then, to visualize the different actions that a user can take and how the program reacts to these actions, we usually put all these features into a nice flowchart. And again, we actually already used flowcharts in some other applications that we built before, right? Now, once we know exactly what we're going to build, it's time to think about how we're going to build it. And this brings us to the project's architecture. And in this context, architecture simply means how we will organize our code and what JavaScript features we will use. So the project's architecture is essentially what holds all the code together. It gives us a structure in which we can then develop the application's functionality. Now, my goal here is, of course, not to turn you into a software architect. The goal of this step is simply to stop and think about how we will implement all this functionality, so all these features, before we actually do it. Because we could implement any project in 1,000 different ways. So we could have one big file with no organization at all, or we could divide everything into functions, or we could use classes, or use multiple files, or a mix of everything. The possibilities are really endless. So we have a lot of choice, and all that choice can sometimes be a problem. And so if we don't think about the architecture before writing the main part of our application, then we will probably end up with a mess of unmanageable spaghetti code. And so that's not what we want. But anyway, once we thought about the project's architecture, we are finally done with the planning step. and are then ready to finally move on to the development step. And of course, this is where we're going to implement the plan that we created using JavaScript code. So let's now plan the application that we're going to build in this section. And so basically go through these 4 steps of the planning step. And we start with the user stories. And remember, a user story is essentially a description of the application's functionality from the user's perspective. And all user stories put together provide a clear picture of the application's whole functionality. Now, there are multiple formats in which we can write user stories, but the most common one is to write sentences with this format. So, as a certain type of user, I want to perform a certain action so that I can get a certain benefit. And so this format of the user story answers the question who, what, and why. Great. And so now applying this to our own Mapty project, the first user story could go something like this. So as a user, I want to log my running workouts with location, distance, time, pace, and steps per minute, so that I can keep a log of all my running. So if we analyze this sentence, then this clearly tells us who wants to perform which action and why. And then, based on this, we will be able to plan the application's necessary features in the next step so that this user story can basically be satisfied. Next up, we can also say that as a user, I want to log my cycling workouts with location, distance, time, speed, and elevation gain, so I can keep a log of all my cycling. So this is similar to the first one, but this one is regarding cycling rather than running. Next up, as a user, I want to see all my workouts at a glance, so I can easily track my progress over time. Then, as a user, I also want to see all my workouts on a map, so I can easily check where I work out the most. And finally, the last user story, which makes sense for this application, is that as a user, I want to see all my workouts when I leave the app and come back later, so that I can keep using the app over time. Now, of course, we could have written these stories in a different way, and certainly different people will come up with different user stories for the same application. But what matters is that we can use user stories to describe exactly what the application will do. And I think that these user stories do a pretty good job on that. Now, in this project, I actually already showed you the working application in the last video, right? But of course, in the real world, you will be building the application from scratch on your own. And so therefore, you will really have to think as if you were the user and put yourself in the user's feet so that you can come up with these user stories and then build your features from there. So let's now actually think about the features. So here on the left side, we have a more boiled down version of the user stories so that we can now work on the features that the application should have. And again, that is based on the user stories. And based on this first user story, we can already imagine a couple of features that our application is going to need. So first, we're going to need a map where the user can click in order to add a new workout. That's because the user wants to log the workout with the location, and so therefore the best way to get the location coordinates is going to be just clicking on a map. Next, since we are working with maps, we should probably use geolocation in order to display the map at the current location of the user, because this is a lot more user-friendly than having the user scroll to their current position, right? So this is a perfect use case for geolocation, and since all browsers on mobile and desktop now support geolocation, this will be a great addition to our application. Then, of course, we're also going to need a form to input the rest of the data. So the distance, the time, pace, and the steps per minute, which is also called cadence. So from the first user story alone, we could already know that we need these three features. I mean, we don't really need them, but they're nice to have because they allow us to satisfy the user story. And so let's now take a look at the second user story. And so for this one, we're going to need a form that is very similar to the first one, but this one has to ask for the elevation gain instead of the steps per minute. Then the user wants to see all the workouts at a glance, and so therefore we're basically just going to have a list with all these workouts. Then the user also wants to see them on a map, and so therefore we will have a feature basically displaying all the workouts on the map as well. And lastly, the last user story basically says that the workouts should of course persist over time. And so there are multiple ways of doing that. And so usually in a real world application, you'll have accounts where people's data then gets stored. But in this case here, since we are just building a very simple application, all we're going to do is to store the workout data right in the browser. And for that, we're going to use a browser API called local storage. Then, whenever the user comes back to the page, we will read the data that was saved in the local storage and then display it both on the map and also on the list. Okay, and so these are the features that we will have to implement. And so let's now put them in our flowchart. Now, the flowchart should of course contain these different features that we're going to implement, but it's also going to contain how the different parts of the app interact with each other, which event makes sense to implement, and also how data flows across the application. So let's now see the first couple of features that we need to implement, and that is geolocation to display the map at the user's location, and then to also display a map where the user can click to add new workouts. And this is how we could put them on the flowchart. But let's actually think together about why we put them like this on the flowchart. So whenever we start to build a flowchart like this, it's a good idea to start with events. And so here in this case, I'm starting with the event of the page loading, basically. And so that's always a good event to start the flowchart, because of course that's always the first event that basically occurs on any page. I mean, it's not an event that we're gonna handle, but as you know, all the code that is in the top level will essentially be executed when the page loads. And so we can count the page load as an event here as well. So when the page does load, we want to start by getting the user's location coordinates using the geolocation API. So just like we decided on in the last slide, right? Then after that data arrives, we want to then render the map basically centered on the current location of the user. Then we also already saw in the last slide that we need a form to input the data for cycling and for running. So we're going to need to display a form, and basically we will display that form or render that form whenever the user clicks on a certain position on a map. So here in this flowchart, as you see, the yellow parts are the actions, and the green parts is basically when we render something on the user interface. And in red, I have marked operations that happen asynchronously. And what that means, we will see in the next video. Now, if the way that I'm building this flowchart here is still confusing to you, then don't worry. So in the future, with more and more practice, you will of course be able to come up with a flowchart like this on your own. So just like everything in coding and programming, this really is a matter of practice. Now just know that in the real world, we usually don't always come up with all the steps in the flowchart right in the planning phase. So it's perfectly okay to just create a rough sketch in the beginning here and then come up with the exact detail during the implementation. So definitely don't get hung up on building the perfect flowchart. Alright, that's just not really necessary in the beginning, and so you should not waste too much time on this. As you become better with practice, this will become easier, and then you might be able to add more and more details to your flowcharts right at the beginning. But when you're just starting out and working on your first applications, then don't stress too much on this. All right, but anyway, let's continue with our features here. So next up, we want to display workouts in a list and on the map. And so therefore, this is what our flowchart is going to look like. So basically, we rendered the form in step 3 and 4, and then we're going to have an event listener on that form. And so then whenever the user submits a new workout, it is going to be rendered on the map and on the list in steps 5 and 6. Then remember, we want to store this workout data in the browser and then read that data whenever the page reloads. And so what's going to happen here is that also whenever a user creates a new workout, it will store all the workouts in local storage. So using that local storage API in the browser that I just mentioned in the last slide. Then whenever the page loads, as we see here on the left side of the flowchart, then we get all of the workouts from local storage and render them on the map and on the list. And of course, that can only happen after the current location has been fetched and the map has been displayed. And so that's essentially what async means. So that red box up there means that it is an operation that takes some time, and only after it's completed, then the rest of the operations that depend on it can be executed. And finally, there is another feature that I didn't mention in the last slide, but which is a nice addition to the way the application works. And so that is to simply move the map to the workout location whenever we click on one of the workouts in the list. And so here in the flowchart, that is also pretty easy to represent. And so basically all we need is an event handler on the list. And then whenever the user clicks on a workout in the list, it will move to that workout's location. All right. And so this is essentially how our application is going to work. And so the features that we need to implement using this flow and this sequence, basically. Now, keep in mind that this flowchart itself actually has nothing to do yet with the implementation itself. So this is just how the program is going to work. And we might very well implement it in some other language. So it wouldn't even have to be JavaScript. So essentially, this is only what our program should do, but not how it does it. So that's more specific, and that's actually for the architecture. And so that brings us to the last part of this planning step, which is, in fact, architecture. Now, just like the flowchart, we don't always need to have the perfect final architecture figured out before implementation. So we can first do some experiments, play around with the code, and only then think about the architecture for the final project in case. Of course, we can do it right in the beginning, but it's not always necessary. And so, to start this project, we will actually simply start coding and starting to implement the features according to the flowchart that we just developed. Then, as we start to need more organization and ways to manage our data, we will come back to thinking about the architecture. All right, and so actually, let's now go do that. So now that you have a good understanding of how we plan a project and build a flowchart using user stories, it's time to start working on the project itself. So let's now learn how to use the Geolocation API. And the Geolocation API is called an API because it is in fact a browser API, just like, for example, internationalization, or timers, or really anything that the browser gives us. And so geolocation is just another API like that, but it's also a very modern one. And actually, there are many other modern APIs like that, for example, to access the user's camera, or even to make a user's phone vibrate. So there's all kinds of crazy stuff that you can do, but in this project, let's simply focus on geolocation. And geolocation is actually very, very easy to use. All you have to do is navigator.geolocation, So VS Code is already showing it to me. And then get current position. And now this function here takes as an input two callback functions. And the first one is the callback function that will be called on success. So whenever the browser successfully got the coordinates of the current position of the user. And the second callback is the error callback, which is the one that is going to be called when there happened an error while getting the coordinates. So let's simply define two functions here. So this is the success one and this is the error one. And let's actually simply start with this one. And here we will simply do an alert. So like this, could not get your position. And now about the success callback. And this callback function here is actually called with a parameter, which we call the position parameter. So we can define that here. And as always, we can give it any name that we want. It is simply JavaScript who will call this function here in case of success, and it will pass in an argument, and we can then use that here. And so for now, let's simply log it to the console. And that's actually it already. Now, just to make sure that we don't get any errors in an old browser, we can test if this navigator.geolocation actually exists. So let's just say if navigation or navigator.geolocation. So if that exists, well, then basically do all of this. So let's check it. And actually, I already have the page running, but it's here on this other side because it takes up too much space. But anyway, here you already see that pop-up window from the browser asking for permission to use your location. And so let's actually start by clicking on block just to see what happens then. And so as you see, this is the situation in which there is an error getting the coordinates. And so therefore, we then get this alert that we specified down here. Right? But anyway, let's go back. And we can then click here on this icon on this right side and then clear these settings. So I have blocked tracking the location, but now I want to actually make it work when I reload. And so I need to clear that setting so that now it's going to ask me again. This time I allow. And now let's take a look at the console. And so here indeed, we get this position object. All right. And the thing that we are interested in is already here. So that's these coordinates with this latitude and this longitude. Let's see what else we have in there. So we also have altitude, we have speed, but these are probably only available like on mobile phones, because I guess that like most computers don't have a way of knowing the altitude. But anyway, let's now get this latitude and the longitude from this object. So remember, they're called latitude and longitude, and they are inside of this chords object. So this is a child object of this bigger object. And so let's now take the positions out of the object. So actually the coordinates out of the object. And so let's simply do const latitude equals position dot chords. And now we could write dot latitude like this, but even better, we can simply use destructuring. And so this will then create a variable called latitude based out of the latitude property of this object. And now the same for the longitude. So just to see if this worked, let's just reload here again. And so indeed, here are the coordinates of my current location. They are certainly not 100% accurate, but we should be able to work with them. Now, what I want to do with these coordinates will be, of course, to load a map and then center that map on this position. And so in the next lecture, we're actually going to do that. But for now, let's simply very quickly create a link on Google Maps. Okay, so let me quickly open up Google Maps here. And so the way the URLs work on Google Maps is that we have this URL, and then here we have the latitude and here the longitude. And so it's very simple to build a URL like this. Let's just copy this very quick. Then here creating a template literal. This part here is not important. And so this here is going to be the latitude. And then here the longitude. Give it a save. And now here is that link. And I think I need to make it a bit bigger here actually for you. And now we can right click here and then open a new tab. And indeed, here is Google Maps on my current location. All right. And no matter where I go, well, actually it changes the URL, so never mind. But yeah, you should try to do that on your own, of course. And then it will take you to your current location where you are right now. So of course, your numbers here are going to look different than mine. But if you create a link like this, then that will take you to your current position on the map. And I think that's really cool already. So this was, of course, just to see how geolocation actually works in JavaScript. And now in the next video, we will use a third-party script to basically load a map and display it here on the right side of our user interface. So on this part here, we want a map, just like in our demo. And so that's going to be the task in the next video. So in this video, we're going to learn how to display a map using a third-party library called Leaflet. So to start, let's quickly Google Leaflet, and probably the first result will already be for this library. So you see that Leaflet is an open source JavaScript library for mobile-friendly interactive maps. So essentially, this is a library that some other developers wrote and that we can now include for free in our own code and use it. And in this case, we can use it to display maps. And whenever we use a third-party library, the first thing to do is to basically include it in our site. And so let's come here to the downloads page. And so here we can download Leaflet to our computer if we want it, or we can also use a hosted version of Leaflet. And this basically means that we can use a version of this library that is already hosted by someone else. So in this case, it is on a CDN, which is a content delivery network. And so it has this URL here. So that stands for unpackage.com. And then here we have the Leaflet library. So actually, we will need a CSS file, and we will also need a JavaScript file. Now, there are also a bit more elegant ways of including JavaScript. For example, using a package manager like npm, and then all we would have to do is npm install Leaflet into our application. And actually, this is how we will do it in the future. So in one of the next sections, we will actually learn how to do this using the npm package manager. But for now, probably the easiest way to get started is to simply include a hosted version that is on a CDN. And so let's grab this code here and paste it in our HTML's head. So right here, and before our own script, and that's very important. All right. So this here is our script. And of course, it is in our script where we will then use the Leaflet library. And so by the time that our script loads, the browser must already have downloaded the Leaflet library, because otherwise our code will not be able to work with that library. That makes sense, right? Now, here we also want to specify actually the defer attribute. So as we learned previously, we should never put any JavaScript in the header without any of the defer or async attributes. And since the order matters here, remember, we must then use the defer attribute. And so this is actually a perfect example for when we need to use defer. Because again, here the order in which the scripts are downloaded is actually very important. Okay, so give it a save here, and then let's go back to the leaflet site. So we already included the library into our site, but of course we need to do something with it. So on its own, this leaflet script here doesn't do anything. So we now need to use basically the functions that are defined in this library to our advantage, and so to actually use the library on our own page. And so down here, there is a very simple example of how we could implement a map with a certain coordinates here, so these coordinates, and then also how to display a very simple marker like this one. So again, let's just go to this overview page here. So basically the very first page, and then just copy this very simple code that we have here. So copy it, and then this is what I actually want to happen when the browser is successful getting the coordinates. So let's paste this here, give it a save, and now of course we need to adapt this here to our current situation. First, let's make this a const and not a var. Then whatever string that we pass here into this map function must be the ID name of an element in our HTML, and it is in that element where the map will be displayed. And so what that means is that in our HTML we need an element with the ID of map. And that should already be here. So that is down here. So here I have this empty div, and it has the ID of map. And so that's exactly this here. So I could change it here, and then of course I would also have to change it in the HTML. Now this L here, this is basically the main function that leaflet gives us as an entry point. So basically this is kind of the namespace, a little bit like, for example, this Intel namespace for the internationalization API. So we talked about namespaces before, and so leaflet basically gives us this L namespace here. And then that L has a couple of methods that we can use. And one of them is this map method. Another one is this tile layer, where we actually need to define the tiles of our map. And then we can also display markers like this. So this should probably already render a map on our page. It will do that on these coordinates, but for now, that's okay for us. So let's just see if this actually worked. Well, let's try to reload here. But for some reason, nothing is happening. So let's check if here in the console, we actually have access to that L variable. And you see that we do. So this L here is of course the L that we used previously in our code as well. So it's this L here, and it is available here in this script and also here in the browser console because it is essentially a global variable inside of the script of leaflet, right? So here in this script that we included here, leaflet.js, the L variable is a global variable that we then can access from all the other scripts. And I think that this is something that we never saw happening before because we never worked with multiple scripts. So let me show it a little bit better to you and include another script here. Let's call it just other.js. So I'm creating it here, other.js. And now let's define first name here, set it to Jonas, and then here in the script.js, I should be able to access that variable. So let's see. And here it is. And so the reason for that is that this first name variable is a global variable here in this script. And so again, any variable that is global in any script will be available to all the other scripts. Well, as long as they appear after that script here included in the HTML. So script.js has access to all the global variables in other.js, or in other.js and leaflet.js. But for example, other.js does not have access to anything from script.js because it appears afterwards. All right. So in other, let's see any variable here. So for example, the month. So here we will not have access to month. All right. So month is not defined. And so the reason for that, again, is that by the time that this script here is executed, this other.js, script.js has not yet been loaded. And so therefore, it doesn't find this month variable anywhere in the global scope. All right, but this was just an example. Let's get rid of this. Well, not get rid, let's just comment it out here maybe. And anyway, maybe you noticed that already the map here has appeared this time. And so what that means is that our code is working. Now this one here is simply appearing in London, and that's because we still have the default code. But now you can probably see that what we want to do here is to use our own latitude and longitude here, right? So let's create an array called chords like this, and it will contain first the latitude, so that's the standard first latitude, and then the longitude. And now let's use that array here, because as you see, this setView method expects this array of coordinates. Then it also expects this second parameter, but let's talk about that one later. So here it's chords, and then let's also use the same coordinates here for the marker. All right, let's check again. And all right, that works. Now here we just have this error from the first variable that we created in the other script. But what matters here is that now we have this beautiful map here right at my, well, approximate location right now. Now that other number that we saw in the function is basically the zoom level of the map. So we can zoom in and zoom out here on this. And so, yeah, let's try with some other values here. For example, 10. Then you see that it's a lot more zoomed out. But let's say we use 17, then that's probably going to be pretty close. Yeah, that's probably as close as it gets. And actually 13 is a pretty reasonable number. So let's keep it at 13. And now let's talk about this tile layer here. So the map that we see on the page is basically made up of small tiles. And these tiles, they come from this URL here, which basically is from OpenStreetMap. And maybe you have heard of OpenStreetMap, and it's basically an open source map that everyone can use for free. And so OpenStreetMap is actually the one that we're going to use, but Leaflet works with all other kinds of maps as well, for example with Google Maps, if that's the one that you prefer. Now we can also use this URL here to change the appearance of our map. So what we see here right now, or hopefully soon, is basically the default map of OpenStreetMaps. Now, however, when you Google around a little bit, you can find different styles. And so what I want to do now is to change this style to another one that I found. And so to do that, you can simply change this one here to FR. And then here it is /hot and another slash, and that's actually it. So that's simply another theme of these tiles. And so if you give it a save, then now you see that it looks different. And in my opinion, that actually looks a lot better. So when you refresh, maybe you see that it builds up basically in these tiles. So did you see that? So basically these map squares, they appear one by one. And so that's what I mean by tiles. So those are the tiles that the map is made out of. Let's just get rid of this error here. And then I think that for now, this is actually enough. So we also have this marker down here. And so that's for this marker plus this pop-up. But let's talk about in the next lecture how we can actually create our own ones and then also display a pop-up and a marker wherever we click on the map. So if I clicked here, then I wanted a pop-up here and a marker. Or if I clicked over here, then I wanted the marker to be here. And so that's going to require a little bit more work. And so let's leave that for the next video. So in this video, we're going to display a marker wherever we click on the map. And for that, we are going to use one more time the leaflet library. And just to make sure that we're following the right path according to our flowchart here, let's take a look at it. And so indeed, when the page loads, then we get the current location, so the coordinates of that. And then after that is done, the map is rendered in the current location. And so now what we're going to do next is to bind an event handler so that whenever the user clicks on the map, we can then display a marker on the map. So for now, we're going to jump this one and continue working with the map. And so we're going to basically render a workout on the map, which is not yet a workout, but we're simply going to put a pin or a marker on the map. And then later we can replace that with the data coming from the workout. All right, so let's go do that. And the first thing that we need to do is to actually add the event handler to the map so that we can then handle any incoming clicks. Now, how are we going to do that? I mean, should we simply attach an event listener to this whole map element here? That wouldn't really work, because then we would have no way of knowing where exactly the user clicked here on the map. So basically, we would have no way of knowing the GPS coordinates of whatever location the user clicked here on the map, because that is data that only the map knows, right? So when I click, let's say here, where I am right now, then I want to handle that click exactly at that position. And so therefore, we need access to the coordinates of the point that was just clicked. So in summary, what I'm trying to say is that we cannot simply use the add event listener method that we have been using all the time. Instead, we can use something similar that is actually available on Leaflet, so in the Leaflet library. And so this is where now this map variable here comes into play for the first time. So when we first wrote this code here, or actually pasted it from the Leaflet documentation, I didn't really explain why we were doing this. So why we were storing the result of creating the map into a variable. But now this is going to be important, because it's onto this map object here where we can now basically add an event listener. So the idea is similar to what we do using add event listener, but on the map we can simply do this. So map.on. And so again, this on method here is not coming from JavaScript itself. It is instead coming from the Leaflet library. So this map object here is in fact an object that was generated by Leaflet. So we can see that because of this L here. And so therefore, this is going to be a special object with a couple of methods and properties on it. And in fact, let's actually start by taking a look at it in the console. So map. And let's see what we get here. So down here it is. Let's get some more space here. And so here you see there's a lot of stuff in here. Also you see that the developers of this library also use this underscore convention here, basically to make these methods and properties protected. And so simply by taking a look at this code here, we already know that we should not basically manipulate these here manually. So let's just look at the ones that don't have this. So there should be this on method that I'm using, but maybe it's simply inheriting that. So let's see. It's also not here. It doesn't really matter anyway. So I was just trying to show you what happens here. But here it actually is. So here is the on method that we are now using basically as an event listener. So here is the on method that we're now basically going to use instead of the standard built-in add event listener method. All right. So yeah, this was really just to show you a little bit the internals of the leaflet library, because I think that it's important that you can also take a look at code written by other people. And so you saw that they also used the prototype chain, and very heavily, in fact. You saw that they also used the underscore convention. And if you want to dig really deep into that code, I'm sure there's going to be a lot of interesting stuff in there. But anyway, let's now add here the event listener basically. And here we can also specify the type of event, and then here our callback function. So again, the idea here is indeed very similar. Now, when Leaflet calls this function here, it will do so with a special map event. Okay? So again, just like in standard JavaScript, we get access to an event, but this one is an event created by Leaflet. So let's just call it map event. And then let's actually simply take a look at this event for now. And so this console.log here should now happen whenever we click on the map. And so again, map is that variable here, which is the result of calling leaflet, so l.map. So let's see. And it always takes a little bit of time to loading this map. So let's just click here somewhere, and you see that immediately we got this event down here, right? And then actually right here in let lng, we then get the coordinates of the point that was clicked. Great. Let's try another one just to see if the coordinates are different. And you see they are a little bit different indeed. And so now we can take this event object, take the coordinates of latitude and longitude, and then add a marker at exactly that point. So we already know how to create a marker, even though this is a very simplistic one. And so we're going to improve it a little bit. But for now, let's just take this code. And then here, let's take the latitude and longitude from this object. So we can destructure this, because remember there was a lat and a lng variable inside of map event dot lat, I think lng like this. But let's check again just to make sure, because I don't really remember it. So the pin from the beginning here is now gone indeed. Let's now click somewhere here. And now we got this pin right here in the center. And that's because we didn't fix our code yet. But for now, I just wanted to take a look. So that's the lat lng object right there. And then in there, there is an object with lat lng. So these are the two values that we just took out of this object. Okay, but now let's actually then put this pin exactly where we click, instead of putting it in the center like we are doing it right now. So this coords here is of course the center of the map that we specified before. So that is coming from geolocation. And now we want to use this lat and lng. So let's specify a new array, lat lng. And here for now, let's just write like workout. And again, we're going to change this in a minute to make it a bit better. But now I'm just interested in seeing if the pop-up is appearing in the right place. And let's wait for it. And there you go. Now I click this one, then here, and indeed it works. So great, that's beautiful already. But now watch what happens whenever I click. So whenever I add a new marker, you see that this pop-up here always closes, right? But in our demo, I actually have it so that they always keep open. So if I click here and add another one, and the data doesn't matter here now, then you see that all the others remain open. And I think that that is actually a better option. All right. You also see that I added some custom formatting to these pop-ups. So for example, the running one always has this green border, while the cycling one has this orange border. And that's because in Leaflet, we are able to add our own class names to the pop-up. So there's a lot of stuff that we can do with pop-ups in Leaflet. And so let's now try to experiment with a couple of them. So it starts here with l.marker. And so this is basically the code that adds the marker to the map. And this one is all still correct. There's nothing to change here. Then here we add that marker to the map. So essentially .marker creates the marker, and then .add2 adds it to the map. And so that's similar to here, where we first select the title layer, and then we add that tile layer to the map, again using .add2. And all of these methods, they are in the documentation of Leaflet, and we're actually going to go there in a minute, okay? Next, we then have bind pop-up, which will basically create a pop-up and bind it to the marker. And so here we simply pass in this string. And so that's why we get workout in all of the markers. But here, instead of specifying a string, we can also create a brand new pop-up object, which will then contain a couple of options. And so that is what I'm going to do here now. So instead of this, I will do l.popup. And then here I can pass in a couple of options. But now let's actually go to the Leaflet documentation, because otherwise all of this will simply appear like magic to you. So I don't want to just write the code here and you copying it. Instead, I want to show you where I'm getting it from in the documentation. Because reading documentation will be something really, really important in your job as a developer. Because as I just mentioned previously, every library that you're going to use will have some documentation so that you can actually know how to use it. Because otherwise, you would have no idea, right? And so reading documentation will certainly become part of the job. So let's just go here to Leaflet. And basically on every page of every library, you will always find something called like docs or documentation. And so here is a bunch of stuff that you can take a look at. Now here, I will just take a look at the UI layers, which are the markers, pop-up, and tooltip. So as for the marker, this is basically what we did before. So l.marker, then add to map. And so this is exactly what we already have. So this is an example, as we can see here, but down here is how we should actually do it. So how exactly this marker function should be called. So we can pass in, or have to pass in, the latitude, longitude, and we can also pass in an object of options. And so here are then all the options that are available for the marker. But in this case, we don't have any. So I'm keeping it fairly simple here. But even on the marker, we can change all kinds of stuff. For example, we could change the opacity, as you see here. We could also like rise on hover, so then the marker will get on top of others when you hover the mouse over it. And so, yeah, you see there's all kinds of stuff that we can do here. But let's now go actually to the pop-up. So you see there's a lot of stuff here. And as always, I encourage you to take a look at it. But now, again, let's talk about the pop-up itself. And so again, here you see that l.popup can take in an object of options. And so this is what we will do now. And that's the pop-up that we will then use on the marker to create a pop-up that is attached to the marker. So the first two that I want to specify is the max width and the min width, so that the pop-up always has a nice size. And so basically, we will now create an object with these two properties. So let's set this one to 250 and the min width to, let's say, just 100 pixels. All right. Now, next up, I want to change that behavior where the pop-up of one marker closes when we create a new one. And so that's this auto close here. So we use this one when we want to override the default behavior of the pop-up closing when another pop-up is opened. And so this is exactly the one we are looking for. And so by default, it is true. And so let's set that to false. So auto close, set it to false. And then finally, there's also close on click, which again will prevent pop-ups from closing, but this time whenever the user clicks on the map. So as we see here, that's the default behavior. And so let's put this one here to false as well. And again, I'm doing all this so that I can show you a little bit how we work with documentation. So finally, we have also the class name. And so as I mentioned before, we can use this one to assign any CSS class name that we want to the pop-up. And so this is going to be useful to style it according to our needs. And so in our CSS, I already have a class for pop-ups. So let's just search for pop-up. So here is a lot of stuff. But the ones that we are interested in is running pop-up and cycling pop-up. So these here are basically styles that I assigned automatically to all the pop-ups in Leaflet. So that's why they have this dark background color and why they have the font size that they have. So all of that I actually already styled here using CSS. But now I want to be able to add a custom class as well so that I can style the running activities with this green and the cycling ones with this orange. So later we will then define this class here dynamically, but for now let's put all of them to running pop-up. And so that's actually already it. Now finally we also need to set then the text back, because right now we don't have any text here in our markers. So if I click here, then you see we indeed get the marker, and it even has this class here. And let's just see what happens when I click another one. And yeah, that works. So all of them stay open just as we wanted. But as I was saying before, they don't have any content yet. And so we need to set that. And that is actually, again, on the marker, I believe. So it's a method that's on the marker. So let's see where it is. Maybe it's one of these ones inherited from layer. So you see that these are basically classes that Leaflet uses. And so then the marker can inherit methods from other classes, essentially. And so here is the method that I was actually looking for. And so set pop-up content is the one that we're looking for, because here we can then specify a string or even an HTML element in order to give the pop-up some content. Now, another thing that's interesting to see here in the documentation is that all these methods always return this. So basically the current object, which then makes all of these methods chainable. So remember how we did exactly that by the end of the previous section to also make methods in our own classes chainable. And so you see that the Leaflet developers are here indeed using the exact same technique. So again, I think that's pretty interesting to see. But now let's copy this method here and add it here. So before we actually open the pop-up here in the next line. And for now, let's just set it back to workout. And Then let's go back and see. So for some reason, this always takes some time. Now here we are. And yeah, now it says workout. They all stay opened. And you see that when we click here, then the map even pans so that it can fit the new pop-up. Great. So this works really fine. But in the final application, obviously the marker is not put on the map immediately because the pop-up itself will contain data about the workout. And so we first need that data. And so here in the real application, when we click, what happens is that this form here opens, right? And so if we take a look at our flowchart, that's also then going to be the next step. So basically we have here render workout form whenever the user clicks on a map. And so in the next lecture, this here is what we're going to implement. All right. So let's now render the workout input form whenever the user clicks on the map. And so just to make sure that we're still all on the same page, right now we basically have an arrow pointing from here when the user clicks on the map to render a workout on the map, which essentially is the marker that we put on the map in the last video. So right now, when the map is clicked here, then a marker appears on the map. But right now, what we actually want in that event handler that we set up in the last video is to render the form so that a new workout can be added. And then on that form, we will add an event listener so that whenever that form is submitted, only then the marker is rendered on the map. And so we will basically move this rendering of the marker to right here. Okay, so let's take a look at our index.html. And so the form that I'm talking about it's this one here. So this form element here with the class form is the one that we want to render now. And as before, I actually already selected it, and it is this one here, simply called form. Let's take a look here again, and you see that right now it has the hidden class. And so one more time, we are going to do DOM manipulation here by adding and removing classes. And in this case, it is our old friend, basically the hidden class. So let's do what I just said, which is that when a click on the map happens, then we want to show the form. And so not this. And so let's get, for now, let's actually get rid of all this. So I will comment it, and later we will need it. And the same actually for this one. And so all we want to do now is to take the form dot class list dot remove and then remove the class of hidden. So let's see. And this is our demo. This is the real one. And as I click here, then indeed the form here showed up on the left side. And now one cool thing that we can do for a better user experience is to immediately focus on this field here. So that's also what happens when we click on the map here. So you see that right away the cursor is blinking there. And so that's actually relatively easy. So all we need is for this input element here of the distance. And again, I actually already selected all of the inputs. And so that's input distance. And we can simply say input distance. So not that one, but this one. And then on that, we can call the focus method. And that's actually it. Very simple, but for user experience, it's a lot better because we can then immediately start typing like this. And now let's add an event handler to this form for submitting it. And for now, we are not going to care at all about the data here. All we want is whenever this form is submitted, that a marker then appears on the page and exactly at the place that was previously clicked. And notice that we actually don't even have any submit button here. So there's no button to submit this form to make it smaller. But remember that whenever we hit the enter key on any of these fields in a form, then that will actually also trigger the submit event on that form. And so that's what we're going to make use of now. And so let's now add that event listener. And so that, of course, we will do outside of all of this. So we will not have an event listener inside an event listener, right? And also this has nothing to do with the geolocation. And so let's do that completely separate out here. So that's form.add event listener. And then, as I just explained, we are going to listen for submit. And so this is the one that will then display the marker. So let's write it here. Okay. And so let's get this code here and paste it here. And of course, getting rid of the comments. And maybe you're starting to notice that we have not only one, but two problems here actually. So right now we are trying to use two variables that do not exist in the current scope. So we are trying to access map and also map event, right? Now this map here is easy to fix. So that map is this variable here, right? So it is defined inside of the callback function of the geolocation API, so of this get current position. But all we have to do is to basically create a global variable here like this. So this one I'm going to call map. And so here we then simply reassign that map to the already existing variable. And now for map event, we actually have to do the exact same thing. All right. So this map event, we get access to it in this event handler that we set up previously. So that's right here. Let's just add a comment here. Handling clicks on map. And don't worry, we are going to fix this entire code here. So this whole mess that we have been building very soon actually. So handling, because yeah, right now it is all a little bit messy, but that's exactly what I was saying in the beginning of this section. So that we will simply start coding without caring for now about the architecture. So without the structure of the code, but very soon we should actually start to think a little bit about this to organize this code. But anyway, it is inside of this event handler that we get access to the map event. So to that object, which will contain the coordinates. However, we don't really need it here, right? So here we are only displaying the form, but where we need it is then later when that form is actually submitted. And so basically as a way of passing it here, we will simply also define the map event as a global variable too. So let me here create also map event. And then here we will have to change the name here. So let's just call it map E, because usually I only call events simply E. And so let's now say map event. So this one here, which is the global variable, should be equal to map E. So again, we did this one here because we don't need this map event right here in this function, which is the place where we get access to it. And so we basically copy it to a global variable. And then here where we do actually need it, we will get access to that global variable and can then use the latitude and longitude right here in this function. And so this will already work at this point. So let's wait for the map to load. There it is. I will click here in the middle of the city. And then again, we don't need to care about the data at all. So I will just hit the enter key. And then maybe for a second you saw it appearing down here, but then immediately the page reloaded. And so the reason for that is because the default behavior of forms is doing exactly that. And so once again, we actually need the event here, and then we need to call event.preventDefault. And so that should now fix it. And so let me click here again. I will just hit enter. And there it is. So now basically the marker appears here in 2 steps. First, the form is displayed, and then when we submit that form, finally the marker is then rendered here on the map. All right, cool. Let's try another one here. Let's just put some values here. But indeed, that works now. Now this form here is far from complete. For example, all the values here should be cleared, and also the form should disappear after we inputted something. But, well, let's take care actually of the first one now, so clearing all the input fields. But then about the hiding of the form, let's actually do that a little bit later. All right. So let's take all the values. So that's input distance, duration, and cadence, or cadence. I'm not sure about that one. So these 3 are these 3 fields. Okay. But then we also have the elevation gain for cycling. And so that's another input. And so we need to clear all of them. Even though this one here is not yet visible, but actually we will take care of that right after doing this one. So let's take these 4 inputs and clear them, and then I will actually show you how we can display this one. So let's do that here. Clear input fields. And so that's input distance. So we can set it equal to the empty string, and then we can actually put them all equal at the same time. So input, let's say duration, then this one, and then finally the elevation as well. So just to test that and to show you the next step here as well. So when we click, let's just put some random values here. Oh, and now we get an error here. So assignment to constant variable. And a good thing that this is happening, because I already remember the mistake that I make. And so that is forgetting the value here. So of course we don't want to clear the entire element, right? We just want to clear the value. So this is one that I keep forgetting. I think this wasn't the first time for some reason. All right, but that actually works. And so now finally, what I want to do is whenever we click on cycling here, then this cadence or cadence should change to elevation. So watch what happens here in the demo when I click cycling. Then both of these changed. And if I click again, then that changes back. And that is actually easier to do than you might think, because there is actually an event which is triggered whenever we change the value of this select element. And so let's now listen for that event, and then whenever it happens, we will then basically hide and display the corresponding fields. So that element that I just showed you is this one. So it is the form input type. All right. So form input type, and so it's this one. It's input type. And so let's listen for the change event on that one. So input type dot add event listener. So again, it is called change. And then let's move back actually to the HTML here, just to see how the form is hidden. And so you see that this here is the elevation field. So you see input and then form input elevation. And so that is exactly this one here. So again, form input elevation. So that's the input elevation. And so this is the element that we're going to work with. So let's actually write that here. So input elevation, but then the one that actually has the hidden class, and in this case, the class is called form row hidden. So let's copy that. And so again, the element that has this hidden class is essentially the closest div element to this input field. Or in other words, it is the closest parent which also has this form row class. And so what we're going to do is to toggle this hidden class both on the elevation gain and on the cadence or the cadence. Because these two rows here, so from these two, there will only ever be one of them visible. So whenever this one is hidden, this one should be visible. And when this one is hidden, then this one should be visible. And so what we can do is simply toggle this hidden class here on both of them whenever this change event happens. So I just said a couple of different things there at the same time. So the first thing that we need to do is to select the closest parent with that form row. And so for that, we use DOM traversal and the very handy closest method. And so here we can now specify the class name, or actually a selector. So here we need a fully fledged selector to select an element. So basically, remember, the closest method is like an inverse query selector. So it selects parents and not children. All right. Then we take the class list and then we simply toggle this class here. And then we do the same on the input cadence. So this one. And so by toggling the same class on both of them, we make sure that it's always one of them that's hidden and the other one visible. All right. So let's wait for it one more time, clicking somewhere. And so let's wait for it. And yep, that works beautifully. So let's just add one here. And indeed, there it is. Okay, so all of this works very nicely now. And the next step here would be to actually take the data here out of the form and then using that data, create an actual workout. However, here in our code, we are at a point where we need some structure. And we will also need a way of managing that workout data that is going to come from this form. So this data here will have to be stored somewhere. And so again, we need to think a little bit about our code structure here and about our code architecture. And so that is going to be exactly the topic of the next video. So before we continue any further in our project, we should now think a little bit about our project architecture. Now, there are some quite advanced architecture patterns in JavaScript, and we will actually talk a little bit about this by the end of the course. But in this small project, we will simply use object-oriented programming with classes, just like we learned in the last section. And so this way, you can then use these concepts here in a real project. And remember that the architecture is all about giving the project a structure. And so in that structure, we can then develop the functionality. And so in this project, I decided that the main structure will come from classes and objects. All right, so let's now dig a little bit deeper into this architecture that we're going to use. So to start, one of the most important aspects of any architecture is to decide where and how to store the data. Because data is probably the most fundamental part of any application. Because without data, it doesn't even make sense to have an application in the first place, right? What would the application be about if not about some sort of data? Now, in this case, the data that we need to store and to manage comes directly from the user stories. So right in the first user story, we can already see that we will somehow need to store the location, distance, time, pace, and steps per minute. And to fit the second user story, we will have to implement basically the same data. So again, location, distance, time, and speed, but then also the elevation gain instead of the steps per minute. And so we will design our classes so that they can create objects that will hold this kind of data. And I believe that this is the best way of designing the classes to really fit our user stories. So you see that we are going to have a big parent class, which will be called workout. And so this one is going to hold the distance, duration, and coordinates. And then we will have a more specific class for the running, which will hold the cadence and the pace. All right. And the reason why the classes are designed like this is because the distance, duration, and coordinates are common to both of the types of activities, so both to running and to cycling, and so therefore they are in the parent class. All right. And the same will also be true for some methods. And so we will see that once we implement it. And then for each type of activities, as you see, we have one child class, so that each child class can hold the data and methods that are specific to that type of activity. So I hope that makes sense. And this is the whole reason why inheritance basically actually exists, so that we can have more specific classes that can inherit behavior and common properties that are common to all the child classes. So the cadence and pace are specific for running, and then the elevation gain and speed are specific to the cycling. Okay? But once again, the cycling also has distance, duration, and coordinates, and so that's why they are there in the parent class, so in the workout class. Then here in this diagram, you also see that we have some other properties like the ID and date, but we will see why once we start implementing the code. And yeah, that's actually it for the data. So this kind of diagram is something that you will commonly see when working in object-oriented programming. So usually each class is represented by a box like this, where in the top part you're going to have the properties and in the bottom part the methods. And of course each class here will have more than just the constructor method. And so that's why I have these 3 dots there. All right. So for now, that's all we need to know about the architecture of our data. But now about the rest of the architecture, it's going to be more about structuring the code that we already have from the previous lectures. And the events that we already have are the loading of the page, then receiving a position from the Geolocation API. So this one isn't an event in the traditional sense, so we're not handling it with add event listener, but we can still classify it as an event. Then we have the click on the map. We have changing the input from cycling to running, or from running to cycling, remember? And then we also have the event of submitting a form. And so all we have to do now is to create different functions that will handle these different events. And in fact, what we are going to do is to create a big class called app that will basically hold all of these functions as methods. So from a quick look at this application class diagram, we can immediately see that loading the page will of course trigger the constructor of the object that we're going to create through this class. Okay? And so then right at the beginning, we want to get the current position of the user using the Geolocation API. And so that's why there is that arrow pointing from constructor to get position. Then, as we receive that position, we want to load the map based on that position. And so therefore, we're going to have a method called loadMap. Then, as we click on the map, we want a method called showForm. Then, as we change the input, we want a method called toggleElevationField. And then, and probably the most important one, is the event of submitting the form. And this new workout method will basically be the heart of this entire class, because this is the one that will create new running objects or new cycling objects. And of course, these objects will be built based on the data that's coming in from the form. And as the user keeps adding running or cycling workouts, a new object will be created for each of the workouts, and each of them will then be stored in a workouts array, which will basically hold all of these objects. All right. So this is going to be an important class property that all methods of the class will then be able to use to work with the workouts. And so with this structure here, we have everything that is related to building the application itself organized into one neat block of data and functionality. And actually, having a class that contains all the data and methods about the application like we have here is a pretty common thing that you will see in simple JavaScript applications like this one. Now, if the application was a bit more complex, then we could divide this architecture even further and create one class that would only be concerned with the user interface and one class for the so-called business logic. So basically the logic that works only with the underlying data. But in this case, we can just keep it simple like this. And so, as I mentioned before, this architecture will then allow us to have everything that is about the application in one nice self-contained block. And besides the application itself, we then also have these classes that are only concerned about the data. And so therefore, application and data will be nicely separated in a very logical way, I believe. Now, what's also great about this is that we will be able to protect all of these methods so that they are nicely encapsulated and not accessible from everywhere else in the code. So that's the reason why you see these underscores on all of the method names, right? So that is, again, the convention that we can use to protect method names from being changed and used from the outside. And so this will make the code a lot easier to work with because we will know for sure that no place else in the code is working with the data and calling any of the methods here. And trust me, with experience, you will really start to appreciate these kinds of things. All right. But anyway, this is the initial approach for our architecture that we're now going to implement. And of course, based on the code that we already have. We will keep adding more methods and properties as we go, but this is already an excellent starting point. So maybe take another minute or two to study this diagram, and then in the next video, we will refactor our code to fit this architecture. Welcome back. And let's now implement the architecture that we just discussed in the previous lecture. And so let's start by implementing that app class that I just showed you previously. And actually, I also have this architecture diagram right here, and it is this one called part 1. And so as you see, this is exactly what we just discussed before. And so I will now go ahead and start to implement this class here and all of these methods. All right. So class app, and then we need the constructor, which for now I'm going to leave empty here. Then we need get position. Next, we need load map. Let's take a look at what's next here. Then we have show form, toggle elevation field, and new workout. So show form, toggle elevation field, and finally new workout. Okay, and so now we have this structure where we can put our code that we already have. So let's start with this one here. So getting the user's current position using geolocation. And so I'm going to start by taking all of this code here. So it ends here, I believe. Yeah, that's the one. Cut it and put it here into get position. But now I actually want to refactor this a little bit better because I think it's still a bit messy to have this callback function here of the get current position function right here. Okay, and so this function here, so this callback of get current position is going to become the load map. Okay, because that is exactly what we do here in this function. So let's cut this here and put it here in load map. And actually, of course, we don't need this function keyword here because we already called it load map, right? So let's just copy the parameter name here and put it here, and then get rid of these. Okay. And so now here, as the first callback function, which is the one for success, so actually here, we need to call load map. And so since we're now in a class, we need to say this dot load map. And so JavaScript will then call this callback function here and pass in the position argument as soon as the current position of the user is determined. All right. And so that event that I just mentioned is basically this receive position. And as I said, it is not an event in the common sense that we used before. So one that we had using add_event_listener, but we can still think of this as an event. All right. And so basically on that event, the this.loadMap method is called. Now here we have some other code. So two event listeners, but for now, let's actually make this code here work. Because right now, of course, none of this will do anything to our application, will it? And why is that? Well, it is because, first of all, we need to create an actual object out of this class. Okay? So right now, this is all just a plan. So like the blueprint of a house, but it is not the actual house yet. And so that analogy is sometimes very helpful. So in this case, this is just the theoretical plan of our application, but it's not a real object yet. And so let's create that down here. And so I will again call this app, but lowercase. And so this app will be new app like this. And this application actually doesn't need any arguments. And so here in the constructor, we don't have any parameters in this method. Okay, because right now we don't need any inputs into our application. If we needed, then we could add that here to the constructor, but in this case, that's just not necessary. One example that we could use for inputs in an application like this would be, for example, an object of options, which is pretty common in third-party libraries. So if we were building a library for some other people to use, then we could allow these developers to customize the library using some options. But again, that's just not necessary in this case. All right. Now, in order to actually trigger the geolocation API, this method here needs to be called, all right? But right now, that is not happening. So how can we do that? We could do this, right? So app.getPosition. And so then this code here would get executed right at the point where the application loads. And that's because, as we already know, all the code that is here in the top level scope, so out here outside of any function, will get executed immediately as the script loads. All right. And so right in the beginning, this new app variable here is created out of the class. And then right now, immediately afterwards, we would get the position of the user. However, why should we do this out here if we could simply do it inside of the class? That would actually be a lot cleaner. So inside of the class, we also have a method that automatically gets called as the page loads. So let's think how we could do this instead. So inside of the app class, we also have a method that gets executed as soon as this app here is created, right? And that is the constructor method. Remember? So this constructor method is called immediately when a new object is created from this class. And this object that is created, so this app object, is created right in the beginning when the page loads. And so that means that the constructor is also executed immediately as the page loads. And so what we can do is to simply get the position in the constructor. And so here all we have to do is to change it to the this keyword, so to the current object, and that's actually it. So our code should actually already be working at this point. So the current position should be determined here in this method, and then the load map method should be called with that current position, right? And actually that's exactly what we also have here in our diagram. So you see the load page events will trigger the constructor, which will then trigger get position. And then as soon as we receive the position, the load map method is called with the position. Okay, and so let's see if that actually works. So here in our version, and let's just reload it manually here. And here we go. So here is our map again. So our first part of the refactoring is already working. So that's great. But now let's go back to our code here, because we still have some things to fix here. So remember that right here in the load map function, we have this global variable here called map. I mean, we don't have it here. We are simply redefining it because it is defined up here in the global scope. But now remember that we actually want everything that is related to our application, and that includes the map, right in this app class. And so therefore, we're now going to define the map and map event as properties of the object. And for that, let's actually use a private class field. So remember that works like this. And so map, and now we will not set it to anything. So just like this, and then the same for the map event. So both of them will now become private instance properties. So properties that are going to be present on all the instances created through this class. Now let's keep them here for now in order to not break the rest of the application. But now we need to fix, of course, the rest of this code. So at least this load map method, because that one relies on map, and so therefore we need to start using it now. So here we now need to actually use this.map, because again, this is now like a property that is defined on the object itself. It's no longer just a normal variable, right? And then here the same, this.map, and here also this.map. And then here we need to define the map event. And so this one we also called this.then hash map event. Now here this is just wrong. So let's fix that. And all right, that's actually it. But actually this will not yet work. But let me show you the error before I actually fix it. So let's go back here and reload this page again. And now it should not work. And so indeed we get cannot set property map of undefined. So on line 38, so that's right here. And so if the error message says that we cannot set map on the this keyword, it means that something must be wrong with the this keyword, right? So let's use our friend console.log to take a look at it. And indeed, it is undefined here. So why is that? Well, this load map method is actually called by this function here, right? So that's right here. And in fact, this is actually treated as a regular function call, not as a method call. So again, since this is a callback function, we are not calling it ourselves. It is the getCurrentPosition function that will call this callback function once that it gets the current position of the user. And when it calls this method, so this function here, then it does so as a regular function call. And as we learned before, in a regular function call, the this keyword is set to undefined. And so that's why in here, the this keyword is undefined. But fortunately for us, there is a good solution that we already know about. And that solution is to manually bind the this keyword to whatever we need. And in this case, that is simply this. So right here, this points to the current object. All right. And so that's exactly the this keyword that we also want inside of load map. And so here we explicitly say that. Okay? And remember that binds will simply return a new function. And so all of this here is still a function that JavaScript can then call whenever it needs to. So that should now work. And so if we go back here, then our map should still work as it should. And indeed, now we get the this keyword here. So we have the map and we have the map event, and we already see that our map is this big object here that is coming from the leaflet library. All right. So that was the most important thing and the biggest thing we had to refactor. But now let's quickly also talk about these two event listeners that we have down here. So the one listening for the event of submitting the form and the one of toggling the input type field. So basically that's this event here and this one. Okay. So where do you think these event listeners should be located? Do you think that they should be outside here, so outside of the class? Well, that doesn't make a lot of sense, does it? So instead, just like before, we actually want these event listeners, of course, to be set right at the beginning. So when a script first loads, but again, of course, that should be inside of the class. And so what is the method that automatically gets called as soon as the script loads? At least in this case. Well, again, it is the constructor. And so we are going to attach our event listeners to the DOM elements right here in the constructor. So, of course, now we want to, again, refactor this code a little bit more and take this function here out of here. So basically create its own function with this code. So that's all of this, I believe. Yeah. And so where should that go? Well, it should go here into new workout. Because submitting the form for the new workout will of course create a new workout. And so that's what this method here is all about. But then here we also need the event, so we can prevent default. And then here again, we have the map event and the map. So we need the this keyword. Or actually here we are just logging it to the console. So there's no need for this one. But here we need this dot map like this. All right. But now, well, let's actually analyze what's going to happen here. So first of all, of course, here we need to replace this one and actually call the new workout method, and actually not call it, but just passing it in, right? Now, keep in mind that this method here is basically an event handler function. So it's a function that's going to be called by an event listener. Now, do you remember what the this keyword looks like inside of an event listener function or of an event handler function? Well, just to make it really clear, let's take a look at it. So let's log the this keyword. All right. So again, we need to wait for the map to load. And now as I click somewhere, then you see we get some error here. So that's on line 60, cannot write private member map event. Okay, so let's go to line 60 and see what happens there. And so that's right here in this event handler function of the event listener on clicking on the map. So remember, this is basically the add event listener equivalent from the leaflet library. So we need to fix this next, but for now, let's go back to the new workout method that we were working on. And so I was trying to take a look at the this keyword here, but apparently that's not possible for now. So let's just remove it here, and I will just tell you the solution. So I was asking you, what do you think the this keyword will be like in this method now? Because this is an event handler function, and so an event handler function will always have the this keyword of the DOM element onto which it is attached. And so in this case, that's going to be the form element. So again, inside of this method here, the this keyword is going to point to form and no longer to the app object. And so once again, we need to fix that using bind. All right. And this is actually a real pain point of working with event handlers in classes like we are doing right now. So even when you're working in the real world and you have event listeners inside of a class, you will be binding the this keyword all the time, because otherwise many parts of your code are not going to work. So again, in this case, because right in this method call here, the this keyword will simply point to the form, but that's just not what we want. In most of these methods, we want the this keyword to still point to the object itself. So in this case, the app object, which is what this is currently pointing to. And so here again, we will need to use the bind keyword. And so this should now work. All right. Then we also have this one here to refactor, but actually there is another method that we want to implement, which is show form, right? And so show form is basically this code right here. So let's just cut it from here, then paste that here. All right. Now we, of course, also need this parameter here. Okay. And then here we will call this dot show form. But now if we run this code, then we will actually get the same error that we already saw the last time that we inspected our code. So the error that we saw previously when I clicked on the map. And so that's going to be this one. And so it says again that we cannot write this map event property onto this object that we are trying to currently. And so once again, the reason for that is a incorrectly set this keyword. So again, this method here is right now being used as an event handler function right here. And so just like in regular JavaScript, the this keyword in this function here will then be set to the object onto which the event handler is attached. And so that's going to be simply the map itself. Okay, and so here we are trying to write map event on the map. So again, the this keyword points to the map because this is where we attached the event handler on. And so once again, the solution to that is to bind the this keyword, because the this keyword is the app object. And so then here, this will also be the app object. And of course, that's where we have the map event property. So right here. Correct? So with that fixed, it should now work. And yeah, it does. And so now we can also test the refactoring of the form that we just did before. And indeed, we get an error. But that's no problem. That is completely normal when we are refactoring. So I'm sure we just forgot like a this keyword on line 78. So 78. Yep, that's correct. So here, of course, we need this dot map event like this. Let's give it another save and another try. And then we're actually almost done with this video. So beautiful. Now it works. And now all we need to do is to refactor this last piece of code that we have in the constructor, because of course we also don't want this function here to be right here in the constructor. So basically every small piece of functionality that is in our application, we now want to be its own function. So let's take this, and for that we have the toggle elevation field method. All right. Now this one here actually does not use the this keyword anywhere. And so here it doesn't matter what the this keyword will be like. And so therefore we don't have to bind it manually here because, as I just said, it doesn't really matter. Elevation field. All right. So now our constructor nicely simply gets the current position, and then it adds these two event listeners to the form and the input type element. So that's very nice and clean. Everything is neatly organized into these methods. And so I think this is a really great structure that we just created here. And now indeed, we no longer need these very ugly global variables that we relied on before. And now let's just test if this one here is working as well. And of course it is. All right. So great. We successfully implemented our architecture, at least part of it. And so now in the next lecture, we will actually implement the rest of the architecture. So that's going to be these other 3 classes here. So I hope to see you there soon. So in this video, we're going to implement classes to manage the data about our cycling and running workouts that are coming from the user interface. And so here we have this diagram again containing the classes that we need to implement. So we already discussed this before, and so let's use this as a base for working on the classes now. But let's also at the same time take a look again at our form to make this a little bit less abstract. Okay, so what both the workouts have in common, so both running and cycling, they have a distance and a duration. Both of them also have a type, of course, but that we will not have to encode anywhere because for that we are already creating 2 different classes. Then for running we have the cadence here, and for cycling we have the elevation gain, as you already know. And then what's also going to be common to both workout types is of course the coordinates that are basically coming from the click on the map. And so let's now start by implementing the parent class for both these workout types. And so remember, that is simply going to be called workout. So workout. And so again, this one will take in the data that is common to both the workouts. And so that is the coordinates. Let's just call it coords, the distance, and the duration. Okay, and then just as we learned previously, we say this dot coords is equal the coords that we get as an input. This dot distance equals distance, and then the same for the duration. Now we could also make these private fields, so basically private properties, but I think in this example we are good like this. We just need to keep in mind later for the speed and pace calculations that this one should be in kilometers and this one should be in minutes. Now what we also want for each workout object is a date. So that's going to be the date where the object is created. So date, and let's simply set it to new date. And so we need this one here to then implement what we have here. So this description of August 20. So here. So basically the date in which the workout happened. All right. And then besides that, we also need an ID. And so that should be a unique identifier. So remember way back in the Bankis project, where we also had an array of objects. And so here we will do the same eventually in our app class. Remember? Now having that array of objects, sometimes we need to find an object in that array. And so back then in the Bankis project, we used defined or defined index methods for that. Remember? However, these methods only work if there is something by which we can search. So some kind of unique identifier. And in the Bankis project, that used to be simply the name of the account owner, but that's just not a good practice. So instead, any object should have some kind of unique identifier so that we can then later identify it using that ID. So let's create a field for ID here as well. And always keep in mind that what we're doing here, so here and actually also here, is using a very modern specification of JavaScript, which is not even yet part of the official JavaScript language. Remember how I talked about that in the last section. And so if we want to make sure that this is going to work at least with ES6, then we would have to do this dot date, and then define that here, and the same here, this dot ID, and then define that here as well, right? However, here I'm simply using cutting edge JavaScript. And so something that's probably going to become part of JavaScript pretty soon. And so I think that it's perfectly fine to use these class fields here already. But now back to the ID. And in the real world, we usually always use some kind of library in order to create good and unique ID numbers. So usually we should never create IDs on our own, but always let some library take care of that, because this is a very important part of any application. However, right now I'm not going to include any library like that, and I will simply use the current date to create a new ID. So new date, and then I will convert that to a string and then simply take the last 10 numbers. And so that should then be unique enough. All right. So converting to a string, and then I can say slice, then the last 10 numbers basically. So this is the workout class, but we will never directly create a workout. Instead, we will always either create a running or a cycling object. So these are the child classes. And so let's create them here. Running extends workout and also cycling. So class cycling extends workout as well. Okay. Then here we also need a constructor. And remember that this one should take in the same data as the parent class and then plus the additional properties that we want to set on a running object. So coordinates, distance, duration, and then remember the cadence, right? So that is what's unique. Well, let's do that here actually. So that is the part that is unique about running. And then here we need to call the superclass with these three. Okay, so the common ones that are common to the parent class. And this will then initialize the this keyword. And then here we can say this dot cadence is the incoming cadence. And then let's simply copy this also for cycling. And here what changes is the elevation gain. So let's check out our diagram here. And so we already have these five. So we have ID and date actually as fields, and then distance, duration, and coordinates, we defined them in the constructor method. Then for the running and cycling, we already defined the cadence and the elevation gain. Now what's missing here is for running the pace, and then for cycling the speed. And so let's actually calculate both of them in each of the class. So in this one here, let's create a method for calculating the pace. So calc pace, and no longer calc age for a change. And so the pace is usually defined in minutes per kilometer. And again, that's unless you are in the US, which probably uses miles per kilometer. So of course, you can also use your distance here in miles. But anyway, all we need to do is to now create this dot pace. So adding this new property basically. And then all we need to do is this dot duration, which is the minutes, and then divide it by kilometers. And so that is the distance. So this dot distance. And that's actually it. All right. Now it might also be a good idea to return this data in case someplace in our code we actually need this. But what we will do instead of relying on this return is to simply call this method right here in the constructor. And so remember how I said in the last section that it's perfectly fine to call any code in a constructor. And so of course we can simply do this right here. And in fact, we did the same here in our app class. So here we also did a lot of different stuff in the constructor, and we didn't even set any properties here, right? So we used the constructor here to immediately calculate the pace. And so next up, let's do the same here for the speed. So the speed is measured in kilometers per hour. And so this dot speed, so not calc speed, but speed, will be equal the distance and then divided by the duration. So the speed is basically the opposite of the pace. So this one is duration by distance, and this one is distance by duration. However, this duration is not in minutes, but in hours, right? And so therefore, we need to first divide this one here by 60. And then we can also return this dot speed, even though right now that's not yet necessary, because we are simply calling it right here. And we don't need the return value at this point. Okay. And now let's just add a comment here. So this one is for the architecture. And then I'm adding like a small divider here. All right. And then let's actually test out these classes. So let's create a run here. So that's new running. And let's see what this class needs. So we need coordinates. And so that's going to be an array of coordinates. And let's just specify this here. So basically kind of as documentation. So an array of latitude and longitude. And so if we have some other developers, they will then know exactly what these coordinates should look like. And there are other more fancy ways of writing documentation, but maybe we will explore that a bit later in the course. But anyway, let's pass in some array here of latitude 39 and longitude -12. And this should then be somewhere in Portugal. Then next we have the distance, and let's say 5.2 kilometers in 24 minutes and with 178 steps per minute. And let's actually do the same for cycling as well. So how do we call this? Is it a cycle one? Maybe it's a cycling like this. So let's use the same coordinates. And then here, let's say we did 27 kilometers in 95 minutes. And the elevation gain was 523 meters. All right. And now we can log both to the console really quick. And so again, this one here is not really part of the application. Okay. This is just to experiment if our classes are indeed working as expected. So going to our application, then you see here that we have our running and our cycling. So indeed, we have all the data that we specified. That includes the date, then here the ID looks a little bit off. And the reason for that is that I basically used new date, which is going to be an object. And so transforming that object to a string will then basically become all of this here. So this string. And so we then took these last characters. But let's fix that in a minute. But anyway, here we have the pace calculated as well. And you see that this is of the type running. And then in the prototype, we indeed have the calc pace method that we just defined previously. And in cycling, we should of course have the calc speed method. And here it is. Okay. And of course, this one itself has another prototype, which is then the workout itself. Now this one doesn't have any methods yet, but we will add them a little bit later as we keep moving on in the project. Let's now fix this ID here very quick. And so instead of using new date, we are going to use date.now, which, remember, simply gives us the current timestamp of right now. And so that will now hopefully fix it. And you see that here we have this ID. And then here we also have the ID. But right now they're actually exactly the same. And so basically that happened because they were created at the same time. But then later in the real world, as we use our application, of course, it's going to be impossible to create two new objects at the same time. And so then that's going to work just fine. However, as I said previously, when you are really working on the real world, then probably you have many users using the same application, right? And then, of course, some users can create objects at the same time. And so by then, relying on the time to create IDs is going to be a really bad idea. All right. So let's get rid of these experiments here. And so for now, at least, our classes here are complete. As I said, we will keep adding some more stuff to them, but for now, we're fine. And so with this, we are now ready to move on to the next video, where we will then use these classes to actually create workouts from the form. So using the workout classes that we just implemented, let's now finally implement the feature of creating a new workout from our user interface. And to start, let's take a look at our flowchart here. And so basically, this here is the action that we're interested in now. So when the user submits a new workout. And so we already added this new workout method here as an event handler function for that event. And so what we want to happen now is to basically render the workout on the map, render the workout on the list, and then this part here we're going to leave for later. So this one is the high-level overview of what needs to happen, but actually there's a lot more things involved than just these immediate actions that we see on the user interface. So actually we're going to leave the rendering here for the next video, because as I just said, there's actually a lot of other stuff that we have to do. All right. So as you see, we are back here at looking at the flowchart, because now we are back to being interested what we actually need to implement and not how to implement it, right? So the architecture here, again, is about how we implement it. And so it contains all of these different methods and these low-level details, while the flowchart here is really more of a high-level overview of what we want to implement. And so for now, we don't need the architecture anymore, because we already put everything into the code that we had here. Now, if you're really curious and want to spoil the experience, basically until the end of the section, then you can already take a look at the final architecture here, but I'm not going to do that. So I just want to now keep building the rest of the application as we go. Okay, but anyway, since this is so high level here, let's actually go to the working demo application and see what exactly happens. So let's reload here. And so let's click just somewhere. And then you see, as we already know, the form opens. Then we can input some data here. And then our application needs to get this data. It needs to check if the data actually makes sense. And then we need to create a new object for this workout and render it right here and also on the map, of course. And then finally, after all that, the form is also hidden. So everything I just said is going to happen whenever we hit enter here. So you see, of course, the marker was created, it was rendered here, all the input data had to be checked, and a new running object was created. So for example, if we add another one, but without any data, then we are going to get this alert. Or the same if we input any data that doesn't make much sense. For example, a negative number for the cadence, which is of course impossible, and so again we get this error here. So input validation is an important part of creating any application that works with user inputs. And so let's now actually work on the function that is responsible for doing all of this. And for starters, I will basically document everything that we need to do here using comments. So first, we need to get data from the form. Then we need to check if data is valid. Then if it's running, so if the activity running, then create running object. And if the activity is cycling, then of course, create a cycling object. Then add the new object to the workout array. And so, yeah, instead of activity, let's actually call it workout here. Then we want to render workout on map as a marker. And finally, we want to render the new workout on the list. And finally, also, we want to then hide the form and clear the input fields. So you see, there's going to be a lot of work. Let's put this one for now, at least, here, even though it's not going to really work like this. But okay, so with this, we now have all the steps lined out. And so let's get started. And we're going to start by getting the data from the form and starting with the type. And type is already stored at the variable input type. So that's all the way up here. Let's bring that down actually. And we could even add these elements here basically as fields also inside of the application. But in this case, I prefer not to do that, because then every time that we wanted to reference one of these elements, then we would always have to use like this.input distance or duration and so on and so forth. And I just don't really like that. But anyway, let's now take the values of input type, distance, duration, cadence, and elevation. And these two here are not that straightforward, but let's see that in a minute. So input type dot value. And so input type is actually a select element, but still we get the value using the value property. Let me just show that to you. And so, yeah, here it is. And so each option has this value. And so for running, the value is running with the lowercase r, and for cycling, the same. Okay, and so again, the value will be whatever of these two is selected, and then we get this value here. And so that will be important in a minute. But anyway, let's now take the distance. So that's input distance dot value. And remember that this always comes as strings. And so let's convert that immediately to a number. And then the duration, let's do the same here. Input duration dot value. Now about the cadence and the elevation gain, we actually don't want to get them here right in the beginning, but the cadence we only want to get if it is a running workout, and the elevation gain we only want to get if it is a cycling workout, because that will then make it easier for us to validate the data. But more about that in a second. So for now, let's actually check what kind of workout we are dealing with. And so all we have to do is to check the type. And if it's running, then we want to get the cadence. So let's call that cadence as well and convert input cadence dot value to a number. But if we are dealing with cycling, then we want the elevation gain. So let's call this one elevation, and here it's also called input elevation. Now, okay, and so now let's check if the data is valid. And so we will now do that inside of each of these if statements. Now you might have noticed that I actually created two separate if statements here instead of an if-else statement. And that's just something that you will see more and more in modern JavaScript. So the if-else is not really that much used anymore. And I think that actually it looks a lot cleaner like this. So to simply have two if statements. So anyway, let's now check if the data is valid. And what does it mean for the data to be valid? Well, first of all, each of them should be a number, right? And so let's do that. And here again, we will actually use a guard clause. So again, what a guard clause means is that we will basically check for the opposite of what we are originally interested in. And if that opposite is true, then we simply return the function immediately. And so once again, this is a trait of more modern JavaScript. So kind of a trend that you will see in modern JavaScript. But anyway, let me show you what I mean here. So if the distance is not a number, and remember that for that, we use number.isFinite. So if the distance here is not a number, then we want to return immediately. So we want to return, and then we can also do some other code here. So let's create an alert. So inputs have to be positive numbers. So for now we checked for numbers, but we didn't yet check for positive. But let's leave that for a second. So we should already be able to test out if this if here is going to work. So let's just see if our map appears here. Let's try to reload here. And for some reason, sometimes this takes a really long time. So sometimes while I was developing this application, I waited up to like 2 or 3 minutes. And I don't know why that happens, but yeah, I hope that never happens for you. But in case you see long waiting times, that might be normal. All right. But now here it is. And so let's input some invalid distance. So like just any letter. And then we get inputs have to be positive numbers. So that is already working. And now we just need to do the same with the other inputs. So we want the same for the distance. So number.isFinite. So actually for duration. And then the same thing for number.isFinite cadence. Okay. Now this is actually not correct because we don't want the end, but instead we want or. So this one here should happen whenever one of these three here is not a number and not when all of them are invalid numbers, right? And so that's exactly what or means. So if this one is an invalid number or this one, then we can get this alert. And so the reason why we did this checking here inside of this if block is because if we did the same out here, then we would also want to check for the elevation. right? But as we know already, only one of the cadence and elevation can be defined at the same time. They cannot both be defined at the same time. And so performing this check would then be a little bit more difficult. So now we can go ahead and do the same thing down here, so in the cycling part, but let's actually refactor this code here already and basically create a small function which takes a number of arguments and will then validate if all of them are numbers or not. Okay? So basically we want it to work like this, but we want to write this in a more clear and more beautiful, so to say, way. All right? So let's create a very simple helper function here. And let me call it valid inputs. So a very simple arrow function, and this can take an arbitrary number of inputs. And remember that when we use REST parameters like this, then we get an array. So inputs is an array, and we now want to loop over this array and basically check if all of them are positive. Now there's actually already a predefined method in JavaScript that is very helpful for that. So remember that we have a nice little method called every. And so let's use it here, and then I will quickly explain what it does. So the current input, and then number dot is finite the current input. So basically this will loop over the array, and in each of them it will check whether the number is finite or not. And then in the end, the every method will only return true if this value here was true for all of them. So for all elements in the array. But if only one of these values here was not finite, so if the result here was false for one of the elements of the array, then every will return false. And so that will then be the return value of this arrow function, right? And so then here we can replace all of this. And let's actually just comment it out. We can now say if not valid inputs, and then pass in the three that we're interested in. So distance, duration, and cadence. And again, here we are inverting the condition, right? So if all of these are numbers, then this here will become true, right? But whenever this is not true, then that's the case where we want to return from the function and show this alert window. All right. So let's copy this and do the same here for the elevation like this. And here I will get rid of the comments. And so this is the first check. But in fact, we also want to test if the numbers are positive, because otherwise they don't make much sense. So let's reload here again. So right now, if I put a letter in any of these, then it's not going to work, right? But if I put in a negative number of steps, then this is perfectly acceptable, and we already get the marker here printed to the map. But in fact, we don't want this to be acceptable. So negative values should not be allowed for any of the three, but in the cycling it should be allowed for the elevation gain. So here we can of course have a negative number, which happens when we go basically down a mountain, right? So that's simple as well. All we have to do is to check if these three values here are greater than 0, and the same for these two, but not for the elevation, okay? And so actually to make this really cool, I will create another small helper function like this one. And it might be a good habit for you as well to get used to these small helper functions. So they are especially nice in these situations for testing complex conditions. So instead of writing all of this and plus checking now for positive numbers, we can simply export that into one or two functions, which then do the job for us. So here I'm going to create a function called all positive. And this one is going to be almost the same as the previous one. So it takes in an arbitrary amount of inputs. And then we will only return true if all of them are greater than 0. And so here the every method is very useful again. So input, and then here we need some condition that returns true or false. And so that's input greater than 0. And so let's now use that here. And so we want basically if all of the inputs are not valid, or if there is basically any number that is not positive. So if not all positive, distance, duration, and cadence. All right. So in this case, we then want to get this alert. And now here, let's do the same for the cycling. But here we are only interested in distance and duration, because again, the elevation might very well be negative. So this is a little bit complex validation, but that's no problem at all. That's why I spent some time here on this validation without any problem. Now it would have been a little bit easier if we didn't have these different values of elevation and cadence for the two different workouts, but we do have it, and yeah, so we have to solve that problem. And so I think it works really nice like this. Let me just check it out here one more time now with these negative values. So if we have a negative distance, then now indeed we get the alert 2, except for cycling. So let's remove that one, and 2, 2, and here -2, but that still works. And so clearly our validation logic here is just fine. Great. So next up, let's see what we have to do. So actually we still have to finish these ones. So if the workout is running, then create a running object, and otherwise create a cycling object. All right. And then afterwards, push that object to the workout array. So add it to the array. And for that, we're going to use the push method as always. So let's start with this one here, right after this guard clause. All right. And so here, let's say workout should be a new running. And now let's see what we need for running. Or actually, we can probably just hover this. And indeed, here we have the coordinates, distance, duration, and cadence. All right. So where do we get the coordinates from? Well, we already know from the marker that they are right here. So in this .map event .latitude longitude. So we know this because we already used this data before to render a marker on the map. So let's get this one and paste it here as the first argument. But actually, this here is now going to be an object. So we know that because here we used the structuring to get the latitude and longitude out of that object. But up here we said, so in the class definition, that indeed we want an array, right? So let's simply get this code from here to up there. So here, and so basically create the latitude and longitude variables here based on this object. And so then here we can define an array with that data. So lat and long. So we already have our array of the coordinates just as expected. And then all we need is distance, duration, and cadence. And then we can take this dot activities, and I think we didn't even create that one yet. So that's up here. And now again, we could do it right here like this. So basically the more classical way. So this dot workouts would be an empty array. But again, in this project, I chose to already use the class fields specification. And so this will become part of standard JavaScript very soon. And so therefore, I can create a class field like this, and I can even make it private, just like the other two. But this time, I actually already initialized it here to a new empty array. And so now we can take that. So here in new workout, we can say this dot workouts dot push this new workout. Now we are going to do basically the exact same thing down here. And so this here is something that always needs to happen. So in both cases, and so let's not repeat that and instead put it down here. But then we have the problem that this workout variable is defined here in this block scope, right? And so because of the scope chain, as we already know, this workout variable will then not be available outside of this block, right? But we want it outside of the block, so right here. And so therefore, we put it right here outside. So let workout, and then here we simply redefine that. And then let's simply take this and put it here again, but this time, of course, with a cycling, and then still the coordinates, distance, duration, but here the elevation. All right. The next step here is to actually render the workout on the map. All right. But before we do that, let's actually take a quick look at the console and see our workout there. And so with that, we can already check if all of this that we have up here is already working, right? Okay, so let's wait for the map. And now let's click here and add a running. So 5 and 25 with 170. And indeed, here we get our running object. So it has the coordinates, and so this worked. And of course, it has all the other data as well. This ID is now corrected, as you see. And also the pace is calculated here based on this input data, right? And so indeed, the most complicated part of adding a new workout is already completed. So that's beautiful. Let's just try the same with cycling. Let's say 10 kilometers in 10 minutes with 30 meters. No, and I didn't even click anywhere on the map. Okay. And so that clearly means that we are still missing a step, which is to hide the form. But anyway, it simply took the coordinates from earlier, and then it added all the correct data here as well. So indeed, it is now a cycling object, while before it was a running object. Let's just do that again here, but this time with clicking, so that I can show you something. All right, so it still says workout, and we're gonna fix that in the next video. But for now, what I want is the cycling actually to have this orange border. So just like this one. All right, so orange is for cycling and green for running. And so let's quickly do that. So in our CSS, I think I showed you earlier that we have running pop-up and cycling pop-up. And these two values here are essentially simply the value of the input type. So this one here. And so here we can simply do a template literal and then plug in the type here. And now actually let's also export this here to its own method to make this add workout method here a little bit cleaner. All right, so let's add down here render workout marker. let's grab this code here. And so now all we need to do is to call this dot render workout marker. And here we need to pass in the workout object, because otherwise it's not going to work. I mean, right now we don't even need the workout yet, but later we will. So we want to display some kind of data about the workout, and so let's pass it in. So workout there, and here let's actually call it workout as well. And so here, instead of displaying this, let's simply display workout.distance. Okay, just for now, just so we are actually using the workout here in this method. Okay, you see that we are also using the this keyword in this method, but actually that's no problem in this case, because here we are actually calling this one here as a method of the this keyword. And besides that, we are also calling it ourselves. So it's not a callback function of any other function in JavaScript. And so therefore, the this keyword in this method here will still be the current object. And so no need to using bind in this case. And so finally, the last step is to actually render the workout on the list. And this one I'm going to leave for the next lecture, because this one is going to take a little bit of time in order to format all the HTML correctly. So let's give this one a save. And so besides that, this one is basically complete. And so let's quickly check it out one more time just to see the cycling pop up. So let's see right there, cycling 10, 10, 10, values don't matter. Oh, and here we do actually have an error, which says that latitude is not defined. And so indeed, here it is not defined. So instead, these coordinates should of course come from the workout itself. And so that itself is already a reason enough to pass in the workout argument here into this function. So now it becomes very important for the first time to have some data in the actual workout object, because here we do need that in order to tell JavaScript, or actually in order to tell Leaflet, where to display this marker. Okay, so it's the data that's coming directly from the workout. And so now this should work, or maybe it shouldn't. So I'm looking at this variable here, and right now the type is of course also no longer defined, right? So we get the type here from this one, but of course this type variable is not going to be available right here. So how do we fix that? Well, ideally we should get the information whether the current workout is of running or of cycling right from the workout object. And actually that's a pretty good idea. And so let's add that value to the cycling and to the running. However, it doesn't make much sense to always pass that in. So we already know that running is always going to be running and cycling is always going to be cycling. And so we can simply add basically that type right here. And so let's do that. So again, we are defining a field here. So cycling. And so this value type will now be a property that's going to be available on all the instances. Okay, so again, this would be the same thing as doing this dot type equals cycling like this. Okay, and now the same for running like this. All right, and so now we can use that here, and we will actually also need that in some other places. And so this is indeed a good thing to have. So workout dot type, and so now this will whether be running or cycling. So let's test that now with cycling. So cycling and we get another error. Okay, So it failed to execute append child on node for some reason. But let's go back to that in a second. For now, I just want to see if actually the type is there. And indeed, it is. So that's great already. Now let's just go back and see why this error here is happening. Well, there's no append child method anywhere here. Let's just set this here to something else. But that's probably not the problem anyway. So probably I shouldn't have changed anything, because now the error message here will be gone, and then I cannot read the stack trace there, which is what we call to that list of errors. Oh, but now it actually worked. All right. So the problem there was that we were actually probably passing in some value that was not a string, and so therefore, for some reason, leaflet created some problem there. But anyway, we will take care of this string here in the next video. For now, I just want to create just a running one here. And so this time it turned out to be green. And so indeed, here the type is now running. All right, so this was a very long video. And so let's finish it here. And as I already said, in the next one, we will then finally render the workout also here on this sidebar.